Hi students, our study today about parity function. First of all, I want to discuss what we mean by even function. Before we start by the definition, arithmetical definition, let us go to graph, to GeoGebra. Suppose I graph f of x equal x squared, for example. As you can see that this f of x, this is the y-axis, and if you the y-axis has for equation, as you know, x equal to 0. So if you pick a point here on this curve, and you do here symmetry with respect to a line, which is the y-axis, you're going to get a point opposite to it. So as you can see, and if you do animation here, what do you realize? You realize that for every point on that part of the curve, you have its image on the other part. And if you pick a point and you do the perpendicular to the other side, so it's the same distance. So this is called an even function. Or if you want more, if you pick, for example, another curve, for example, a curve, any curve, f of x equal, for example, x squared minus 2x minus 1. So this is the curve we have graphed. If I do f of minus x, and if I keep x as it is, because f is y, if I keep it as it is and I put opposite sign, you can see the blue curve and this curve, the purple one, are symmetric with respect to y-axis. So if you pick here a point on that side and you do the symmetry with respect to this line, the y-axis, you have a point opposite to it. So by definition, as you can see here, you can look at it. So if you replace, because symmetric function, if you replace x by minus x and you keep y as it is, nothing will change. This is called a, an even function. I mean here, let me do the same example that I did before. So here, if you pick a point here, as we said, and you do the symmetry with respect to that line, you have a point opposite. These 2 points have the same y, but same y as you can see, but the opposite x. So this is called an even function. So for now and on, if you replace x by minus x and you keep y as it is, nothing will change, is an even function. So the definition, arithmetical definition, if f of minus x, if you replace x by minus x, you're going to get the same y, which is f of x, nothing will change, is called an even function. Example of even function, any x power to an even number, positive or negative, is even. Absolute value of, because absolute value of minus x is x. And if any number raised to, for example, if you have, for example, minus x, if we replace x by minus x, we said we replace x by minus x, and power is even, for example, 2n, the minus will disappear, so nothing will change. And cosine minus x, also cosine minus x is cosine x. These are example of an even function. So let us go to some application. We're going to check if this function is even. As you can see, to check if the function is even, you can do it directly. Power of x is 4 even, power of x is 2 is even. 5 has, for example, 5 is written as 5x power 0. So the power of any number, any coefficient number, real number, is even because it can be written as x power 0. So this is even. If you want to do it step by step, we said that to be even function, you must have f of minus x must be equal to f of x. Okay, so if you replace here x by minus, since all power are even here and here, so nothing will change. So you're going to get the same one as we did above. So it's even. And even for cosine, cosine minus x is cosine x. And here, if you replace it, this is also even. Here it's not even. Why? Because power even, here power odd. So it's not even because this minus here will not disappear, so it's not the same. So to be uneven, you must have sum and difference of all even. You know, sum of evens is even and difference of even is even. But sum of an even function with a function which is not even, like here odd, is not even. So let us explain now what we mean by odd function. Odd function is a function which is symmetric with respect to origin. For example, origin here, let me give you an example of origin. So let us do it. I'm going to pick the origin, which is a point here, O00, O00. So anyway, let me pick this point, and here. So if you pick now a point and do symmetry now, not with respect to a line, with respect to a point, A to B, you're going to get here, as you can see, B prime. And if you join these as a segment, you're going to see as A is moving, A will move on the other side. So let us see it. As you can see, this is an odd function. It is symmetric with respect to the origin, as you can see. Okay, and more to be an odd function, if you replace, for example, here, if you have a point xy, as you can see here, opposite x and opposite y, here minus plus plus minus. So if you pick here a point, for example, point here, any point, and you do again the symmetry with respect to the origin, this is point C, as you can see, 1.59. You're going to get the same one, but opposite x and opposite y. So now let me take any function and do the symmetry. You can see now very clearly. If you have, for example, f of x equal, for example, 2x minus 3. And if you replace this f of x by minus f of minus x, what I'm doing now, I'm changing x to y. I'm replacing x by minus and y by minus. So if you pick here, if you pick the origin here, if you pick a point on that side, and you do the symmetry, it will be on the other line. The symmetry with respect to a point. So if you do the symmetry, you're going to get just the opposite. And if you join it in a segment, you can see, and you do the animation here, you can see because I replace x by minus x and y by minus y, you're going to get the point on the other curve. So this is enough for GeoGebra. So for the odd function, as we said, symmetric with respect to origin, if we replace x by minus x and y by minus y, nothing will change. The function will be what? Odd function. So it's f of minus x equal minus f of x. Example of, sorry, here of odd function, because I do sometimes copy paste here odd, it's not even. Example of odd function are f of x equal x power n, where n is odd. Sine x is odd function because sine minus x is minus sine x, and tangent minus x is minus tangent x. In other words, the minus will remain. So let us take examples of odd function. Here, to start, we do first of all f of minus x, then we put minus before. So if you replace here x by minus, here as you can see, odd, 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 the sum of odd must be odd. So this minus will be outside, this minus will be minus times minus is a plus, and this minus before sign will go out. If you take minus outside and you put big parentheses, you're going to get 2x cubed minus 3x plus 5 sine x, which is f of x. So it will be minus f of x. So this is odd. First of all, it's not even because f of minus x here it is not equal to f of x. It is here minus f of x. So this is odd, not even. Another example here, if you replace x by minus, here as you can see, odd, odd, and here power 1 odd, so sum of odd must be odd, so directly you can write it as odd. But if you want to do it step by step, you replace x by minus, here x by minus, here x by minus. So because tangent is odd, minus outside, because power is odd, minus times minus plus, here minus and minus plus. So you have the same one f of x, but opposite, all opposite sign. You can put minus before. So this is an odd function. Here is an example of not even nor odd. Why? Because you have a sum of odd, then 1 is 1x0. x0 is even the power of x. So it's neither. Why? If you start by checking the even f of minus x. you're going to get minus 2f of x5 minus plus 3 لأنه power odd minus goes out minus 2x minus 1. So it's not the same. And even if you put minus, big minus, and you're right, you're going to get 2x5 correct, minus 3x cubed correct, plus 2x correct, but you're going to get plus 1. So here you have minus 1, so it's neither even nor odd. So you can do it directly because you have sum of odd and even. So like 1x0. For example, x cubed plus x squared is neither even nor odd. Why? Because you have sum of odd, we have power of odd and with power of even, so it's neither. So let us go to some properties. As we said, sum of two even is even, sum of two odd is odd, like we said before. Difference between two odd, certainly it's odd. Difference between two even is even, but sum of even and odd, like I said now is neither even nor odd. For multiplication, this is very important. Product of even and even, I'm going to take even to be plus. Why? You're going to see it will help us a lot in exercises. Even, suppose even is a plus. Plus times a plus is what? Plus. So even times even is even. Product of two odd, suppose odd is minus. Minus times minus is what in plus, and plus we name it to be what? Even. So the product of even and odd, plus times minus is what? Minus. So product of minus of odd and even is what? Odd. The quotient of two even, plus over plus is what? Even. Plus. It's plus. Plus we denote it by even. The quotient of two odd minus over minus is what? Plus. So it's even. The quotient of an even and the odd minus over plus or plus over minus, it's minus. So that's why the even we're going to take it as a plus, the odd we're going to take it as minus, and sum of odd must be odd, sum of even must be even, but sum of even and odd is none. So let us go to some applications. Here I have many application. Here we're not going to do it like we did before, f of minus x or minus f of minus x. I'm going to follow. Here you have power 1, here power 0. Sum of even and odd is none, because here is odd, here is even, here is odd, so here is none, and it means none. Here it's only odd, so this is odd. Here power 1, 1 is even, plus over minus, so it's minus, so here it is odd. And example number 3, even and x power 0, sum of even is even. X cube and x1, sum of odd is what? Odd. Here even, odd, sum of odd and even is none. Cosine x is even. This is x squared even, and 5x power 0 is even. This is what? Even. Here, product, I have a product. Minus, sine is odd and tangent is odd. So minus times minus is what? Plus. So here all of that is plus. Then this is even, this is even. Sum of even plus even is what? Even. Here x is odd, cosine is even, plus minus times a plus is, as you know, is minus, so it's odd. Here this is odd. Then I have a sum or difference of even, so this is what? None. Here odd plus odd is odd, minus, and sine x is minus, minus times minus, this whole thing will lead us to plus. Then I have addition with even and addition with even, so this is even. Here even, so plus, tangent is minus, plus times minus is minus, so the whole thing here is minus, plus minus, sum of two odd is what? Odd. Here 2x minus sine x, this is odd. Odd power 5 minus power 5 is minus. Here odd, and here tangent is odd. Sum of odd plus odd plus odd plus odd, it is odd. Okay? Here odd power 5 is odd, minus power 5 is odd. Here is odd, here is odd, here is odd, here is even. You have sum of odd plus sum of even, so this is none. Here this is what? odd. Sine x is odd. Minus x power 1 is odd. Odd power 4 minus power 4 is a plus. Plus times minus is minus. So here this is odd. This is odd. This is even. So sum of odd plus even, because x power 0, this is what? Known. Here this is odd sine x times, here it's odd, minus times minus, because you have x cubed and x power 1. This is a plus, so this is even. Here cosine x is even, x squared is even, 5x power 0 is even, sum of even is even. So let us continue. Absolute value, here even, all is even. Absolute value of plus, as you all know, is a plus. So even plus even plus even is what? Even. So the first one is even. Here, odd, x cubed and x odd, but you know absolute value of minus is also plus. So 2 times a plus is a plus, because 2 is even, plus times a plus is a plus. Here is even, here is even. Sum of even is even. Here you have x cubed even and sum with odd, so this is none, because we cannot add plus to minus. Here this is odd. Absolute value of minus is a plus. Plus times minus is minus. This whole thing is minus. Plus odd minus plus minus is odd. Here absolute value, this is odd. Absolute value of minus is a plus. And x4 is even. So plus times a plus, this whole thing is a plus. Here even, so this is all even. This one here, odd, absolute value of odd is a plus. Plus times a plus here, because even plus even, this is even. Here odd, even, so none. Sum of even and odd is none. Now up x7, x5, this is sum of odd is odd. Here sum of even is even. Minus over plus, you all know it's minus. So here it's odd. Here odd, so up is minus, down odd, and cotangent is like tangent. Cotangent like tangent. So minus over minus in odd, because tangent is odd, cotangent is also odd. Minus over minus is what? Plus, so this is even. Here even, so plus up, even, plus over plus is even, plus. Here, this is odd, this is odd. Absolute value of minus is positive, plus positive because power even. So plus, down is odd because all power. So this is what? Minus, which is odd. Here, odd and odd, sum of odd is minus. Here is a plus, plus times minus is minus. Plus minus, so it's odd. Down odd and odd minus, so minus over minus is a plus, which is even. Here also odd, like up, times odd, so minus times minus is a plus, and plus odd, even plus odd is none, no need to continue. Here, x cubed, x squared, so directly none. Here it's plus, here it's minus, minus power 5 is minus. Minus holds because power 5. Minus times the plus is minus. So this is all odd. Plus odd, so minus. Down odd, minus over minus is a plus, so which is even. Here power 8, odd minus power 8 is a plus. Even, power 9 plus power 9 is a plus. Here odd, absolute value of minus is a plus. So plus times a plus times a plus, so this is a plus even. Here, when you have y square, for example, if you replace, here I'm not going to do it as I used to do up. We're going to do it. Let us check first of all if it's even. If you replace x by minus, minus times minus here is a plus. As you can see, nothing it will change. So this is even, because if you replace x by minus x, remember the definition of even. If you replace x by minus x and you keep y as it is, nothing will change, it's even. So here minus times minus plus. For odd, if you replace x by minus x and y by minus y here, nothing will change, it's odd. So this is odd y. because if you replace y by minus, since y you have it square, so nothing will change. If you replace x by minus here, minus times minus is also plus, so this is even and odd. Here it's the same case, it's even and odd. Why? Because if I replace x by minus x, nothing will change because even. And even if I replace x by minus x and y by minus y, nothing will change. This is odd. But if you had y cube, only it will be even, but not odd. Because if you have, for example, 2 y cube like y cube like y, minus 3x squared equal to 4. This is even. Why? Because if you replace x by minus x, nothing will change, so this is even. But for if you replace x and y at the same time, here you're going to get minus 2y cube minus 2y cube minus 3x squared equal to 4. So it's not odd, so here it's only even. I hope that you got this lesson, and thank you for listening.